Year 12s. Today we're doing exercise 22E and it is called linear representations of nonlinear graphs. What that means is we've got a graph that's not a straight line and we have to make it a straight line so we can find the relationship between the two variables. Anyway, copy down the notes first and then I'll explain it all. Cool. So remember to pause the video. Alrighty, okay, so let's start from here. Let's look at the graph of this parabola. So remember, a parabola is in the form of y equals x squared. Because it's x squared, we know it's a parabola. Looks like that. We're only looking at the positive section of this, and that's why I put that as a dotted line. Alright, so we notice that that is not a straight line when we plot y against x. It's a parabola, it's not a straight line. So, if we plot y, the same values, y against x squared. So this value here is x squared instead of x. Then if we plot those same values, we'll get a straight line. And what that means is that there's a relationship between y and x squared. And the key to this is that, remember from last lesson, y equals kx squared, where k is a constant. K is the gradient of this straight line. So once we have this straight line plotted, we can find the gradient, find any 2 points, rise over run, find the gradient, and that's the k value, and that goes in front of that equation. And that's all you have to do. So remember, if you've got the two variables and you graph them and it's a straight line, then you know that's a relationship. So in this case, y is related to x squared, so it's y equals kx squared. Alright, let's do some examples, I'll show you what I mean. Okay, so we've got a table of values here. There's x and the y values. So x goes from 1 to 4, so only this positive section, and they're the y values there. So we want to find, ideally, we want to find the relationship between x and y. Is it a straight line? Is it a parabola? Is it a cubic, perhaps? So, first, part A says plot the points. So, I'm not going to do this exactly, but when we plot the points, you probably get a graph like that. It could be a cubic, it could be, maybe it's a parabola. So you plot those points, you all know how to do that. The first point is 1, 1.5. So you plot the point, 2, 6, you plot the point, and so on. So you'll get a graph like that. Okay, so we know that there's no relationship, so it's not a relationship between y and x, so it's not a straight line. So we move down here, and part B said plot y against x squared. So before we do this, we need to add on another section to our table of values, and we'll call that one x squared. So you can either fill this in manually, so square the x value. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. You can either do that, or on your CAS calculator, in the table, if you put those values in, you can just make the next column x squared, and it will do it for you automatically. But in this case, it was pretty easy. So now I'm going to plot the points, the x squared value against y. So I'm going to plot, the first value will be 1, 1.5, so wherever that is. Then the next value will be 4, 6. So I'll put that value there, 9, 13.5. So of course you'll have your scale across here and you'll plot these points accurately. And when you plot these points, you'll notice that it's a straight line. So what does that mean? It means that there's a relationship between y and x squared. So, and what is it? Because we've got a straight line here, we know that y is equal to k, which is a constant, times by x squared, because it's a parabola. We know it's a parabola because we've got a straight line when we plotted y against x squared. If this wasn't a straight line, then perhaps we'd try y against x cubed. And then if that worked, then that was a straight line, then you'd know it would be a cubic, and it would be y equals kx cubed. But because it's a straight line, then this is our equation. So now we substitute any known point in. I picked an x and a y value, so I picked 1 and 1.5. Nice easy values. So I substitute them into this equation. So y is 1.5, and x is 1. So 1 squared is 1. You work backwards, you get k is 1.5. So our equation here is y equals 1.5, whoops, sorry about that, that should be x squared. squared. Change your notes, everyone. So y is 1.5 x squared. And that's the equation of from our table of values. Good job. Let's move on to the next type of question you might get. Alright, find the rule of the values given in the form y equals kx squared plus c. Okay, so it's telling you it's of the form y equals x squared, something x squared, so we know it's a parabola. Okay, so we've got our table of values there. So what do we need to do first? We need another section in here. So I've run out of room, another section, and we call that x squared. So we square all these x values. 0 squared is 0, 1 squared is 1, 3 squared is 9, 5 squared is 25, and 7 sevens are 49. Alright, so now we plot y against x squared. And when it says it like that, just make sure y is on the y-axis. Something against x squared. So we plot these points, 0, 0.5. Again, I'm just going to do it roughly 1, 3, 9, 23, 25, 63, whatever it looks like. And we do get a straight line. So of course, if you did this in a test, you'd actually have your scale across there and do it nice and accurately. Because plot means do it accurately, you're plotting the points. A sketch is different, that's where you just roughly put a line that looks like what it should look like. Alright, so there's our graph. So we've plotted those two variables and we've got a straight line, which means there's a relationship between those two. Now, it says find the values of k and c. So k is there, that's a constant in front of that, and that's a gradient, remember? And c is the y-intercept. Alright, so let's have a look. Find the values of k. The gradient from the graph, so when you do this accurately, again you'll find rise over run. So you'll find your gradient, and we've worked it out at 2.5 if you do it accurately. So we've got k is 2.5. So now I can rewrite my equation, y equals 2.5 x squared plus c. Because we know that 2.5 is a gradient from the graph. Now I'm going to substitute in the x value and the y value, so 1, 3. I picked it from here, x is 1 and y is 3. So I just substitute 1, 3 into this equation. And what are we going to find? We're going to find the c value. So 3 equals 2.5 times 1 squared. Work backwards and you get c is 0.5 or a half. So then you write down your equation. We've found out the value of k. We've found out the value of c. You substitute them in to the original equation up there. So y is 2.5 x squared plus 0.5. Good job. I'll be back in a sec. Hi everyone, welcome back. Our next example is finding a rule using CAS. So this time we're not going to graph it ourselves. Look at the numbers, they're all funny decimals in there. So there's nothing we can really do manually. So copy down those notes for a second. Okay, so this is just a bunch of commands that you press using CAS. So the first thing is go to statistics, enter the data into columns. So you enter all those into x and y, but very important, don't put in 0, 0, or else the whole thing won't work. So you ignore 0, 0 at the start. Okay, and you go to Calc, Regression, and then there's another button called Power Reg, or Power Regression. Click on OK, and it's as simple as that. Type that in, and then this will pop up. It'll say y equals ax to the power of b. Now remember, we don't know what type of equation it is. It might be a straight line, or a parabola, or a cubic, and that's the value of b up there, in this case. And then, but it came up with that information. A is 3.5, which is there, and B is 3, which is up there, which means it's a cubic. So all you do is substitute those values in. So y equals 3.5x, and it's to the power of 3, so cubed. And there's your equation. You're done. So that's using CAS, everyone, but it's good to know also how to do the graphing before, like in the other examples, and being able to find the equation. Have fun. See you, everyone.